Welcome to Fluids and Electrolytes. Here is a little introduction to fluid and electrolytes. Please read this section, especially as it relates to our homeostasis and how we have a balance. I have a little paper I want to show you. So this is my little take before you try to understand the fluid and electrolytes and how we give IV fluids. I have my little man over here. And so water, what happens when we're drinking water and where it goes? So on average, a person weighs about 70 kilograms. So we have about 60% of water in our body. So if we multiply the 71 kilograms by 0.6, that equals 42, which is about 42 liters. So 1 liter of water weighs about 1 kilogram. So that's the comment it's important that we can educate our patients about how much fluid they're retaining. And we know that 1 liter of water weighs about 1 kilogram. So 2 liters is about 2.2 kilograms. So now let's ask what a water in a person is. So it can be inside cells, like the muscle cells. Got muscle cells here, or where else do I have? Our cells are always bathing. So here is the excuse me. They're also bathing in water as seen. I have this below, but I have it next to you so you can see it. And the red and the orange circles are the cells, and the blue line shows the fluid around them. Okay, so the 42 liters for the 70 kilogram person looks at it. So 2/3 of fluid is in the intracellular compartment inside the cell, intracellular, and which is about 28 liters, and extracellular compartment outside the cell. So inside the cell, outside the cell is 1/3 or 1/3 for 14 liters. They are called compartments because they are sealed off from each other by a cell membrane. But realize we have trillions of cells, but because one cell is full of fluid, ions, and cellulites. So I do have something else here down here to show you. Here's my little guy again, but I just wanted to show you this little graph. I'm not sure if I can get it all on here at one time, but I just wanted to show you how with the 42 liters for an average person, and we're talking about an average person now. So you have extracellular compartments, which is about 14 liters, which is about 1/3, and then you have your, let's see if I can scroll this up a little bit more. I'm not sure if I'm able to get my bar down, but you have the remaining 28 liters, which is 2/3, which is intracellular compartment, okay? Inside. Extracellular, it's about 1/3, and intracellular. That's my little take on fluid. So now let's talk about some of the electrolytes. In your chapter readings, it have a movement of body fluids and electrolytes. So I thought this section would be very important for you, and I'm trying to figure out where I'm at on the page. It's page 1310, 1310, movement of body fluids. So I want you to read this information. So when you're getting electrolytes for the nerves and IV fluids, you understand what you're getting. So especially osmolality, osmotic pressure, things are right here so you can understand the fluids that you're getting. So mainly in here, I would like for you to pull out, in relation to the body fluids, an isotonic solution has the same osmolality as ECF. Normal saline or 0.9 sodium chloride is an example of an isotonic solution. So I might say, can you get an isotonic solution? You're like, oh my gosh, what is that? So you look, it's your normal saline. So hypertonic solutions such as 3% sodium chloride have a higher osmolality. Okay, so hypotonic solutions such as half normal saline or 0.45% sodium chloride have a lower osmolality. So there's a table on 52-10. I'm not sure if I'll be able to show you that really quickly. I'm just going to scroll through this so you can see what the osmosis. This was all taught earlier. So if you want to just review, I'm sure you know this, the transport, active transport. But if you want to review, you can. It's all here in your book. But regulating body fluids is very important. Okay, so don't forget about when we're doing our fluid intake. We're doing our oral fluids, water and foods, water as byproduct of food metabolism. So we have a lot to look at when we're doing things. Remember, we have a lot we have to do. We have to monitor the intake, we have to monitor output, we have to do our assessment, our signs and symptoms. There are lots of things that we look for. So look at your daily, here, let me just scroll up. This is your table 52-2, average daily fluid output. And look at that. Look at the sensible loss. There's 0, but in your lungs, look how much we put out. We breathe. That's why I was telling you guys in class, we breathe in moisture. Look at our skin, our sweat, our feces. So we're supposed to put a pretty good amount of output out. So the most important thing I want you to get out of here is knowing that your intake and your output. This is another take on what we just read from the book. It's just kind of all like squeezed into the slide. But look here, intracellular compartments rich in electrolytes. Intracellular, so your potassium, magnesium, those things are inorganic and organic phosphates and proteins. So know that. So external body fluids. This is all a retake of what we just saw in the book. But look at your extracellular compartments. Is rich in sodium, chloride, bicarbonate. So remember, when serum electrolytes are drawn, it is the extracellular fluid that is measured for electrolyte levels, not the intracellular fluid. Okay, very important to know. So let's just bring back memories about your cations and your anions of what you learned prior to coming to the nursing program. It's coming back, so it never goes away. So within a single cell or the body, there must be a balance of electrical charges. So just read this and see if that knowledge is coming back to you of what you learned in the classes prior to your, I believe this would be your physiology class, possibly your micro class that you learn this information in. Now the next slide is going to go over some regulation of fluids. So here we go. So you have your 0.9 normal saline. Remember we talked about earlier, it's isotonic, remember. So look at this, the amount of water transported into the cell equal to the amount of water transported out of the cell. It's going in and it's going out, okay? You have your hypertonic, that's with some dextrose in there. Dextrose, D5 normal saline, or we say D5 normal saline. Okay, and then don't forget to look over here at your hypotonic. Remember we talked about that a little bit earlier about the cells and the half normal saline that you have. Now look what happens when we have problems with transporting our fluids. Sometimes patients get third spacing, fluids where it is not supposed to be. Okay, so symptoms of third spacing, blood pressure is low because it's not in the cell, it's third spacing. Heart rate goes up high. Thirst, they're very thirsty. Urine output is low and they're very tired. Third spacing, okay? So it's not, this fluid is not in the cell. Remember that when you're third spacing on the fluids where it's not supposed to be, one of the early signs is thirst. Thirst. We went over the little arrows that was on the slide earlier. I'll go back and then I'll come to this one. These little arrows here are what we're talking about. Uh-oh, I went the wrong direction. Sorry. It's what we're talking about here with the low urine output. It's just basically a repeat, but this is important. Normal urine output for adult is 0.5 ml per kilogram per hour. Very important. Okay, concentrated urine with high specific gravity. They have a specific gravity of 1.010 to 1.030. Okay, so we know that, but I need to make sure that you really write this down in your tablet somewhere until you remember it. Normal urine output. Okay, I'm not going to beat that to the bones, but they also have a low-grade fever, high temperature with severe dehydration, okay? High temperature with severe dehydration. Altered level of consciousness and labs, you have hypernatremia. That's high sodium, right? Elevated BUN. What is this talking about? Our urine, our kidneys, right? High hematocrit, low specific gravity. Make sure we know those things. Here are more of clinical assessments. I won't read them off each to you. I don't want to bore you, but they're here. I think I have one of them kind of blocked off a little bit. There we go. Am I still recording? Yes. So they're here. Please look at these, and they're in red for a reason. So here I talk about a little bit of dehydration and hypovolemia. The volume is low. So you look at this serum sodium level. It rises in the vascular system due to fluid loss. Osmosis causes water molecules to shift from the cell into the blood cell vessels to maintain homeostasis. Remember we talked about homeostasis earlier in the book? We're bringing it back here. So look at each of these bullet points, and I want you to read those. I'm not going to read all of, the PowerPoints off to you where you can, but if you misunderstanding, you definitely need to come to me so we can make sure we understand it. Okay, but just think about here, hypovolemia, hypotension. So you're going to look at the vitals, okay? And then as we keep going on, we have our clinical assessment of fluid overload. Overload. You know how you're doing your assessments on your patients and you're checking for JVD? You're checking to see if that patient has fluid overload. Peripheral edema, you're looking for JVD. What should the head of the bed be? 45 degrees, right? Or higher. You're checking the liver. You're checking for the breathing. Are they breathing fast? Are they have a cough? Is that cough moist or productive? That's a late sign, but still, you want to see about the work of breathing, because remember, you have fluid overload. The heart is beating extra harder. You could have a backflow. So remember the route of the heart, okay? So also BU and creatinine, remember, could be increased. Decreased hematocrit, because we're looking at the volume, we're looking at all of this. So make sure you understand these labs, and I spoke about that in one of the other slides. Make sure you understand the BUN, decreased hematocrit. Make sure you understand what hematocrit is for. Make sure you understand what sodium, potassium, all those things are for, okay? And we're not going to really talk about employee safety because you guys already saw a video on OSHA, so that will cover these slides here, okay? So you already saw the OSHA video and you've already done the testing on that. So thank you for listening. It's 12:47. Let's end this slide so I don't go past 15 minutes, and so therefore I can keep your attention. Thank you so much, and we will see each other in class.